Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own Mass Coder this side. So welcome to lecture number 27 of the linked list series, and in this video we're going to discuss the question segregate even and odd nodes in a linked list, right? Okay, now what does the question say? The question is actually very simple. You can see I have a linked list with me, right? 17, 15, 8, 9, 2, 4, 6. I can see some values are odd, such as this is odd, this is odd, this is even, this is odd, this is even, this is even, this is even, right? Now the question wants me to reform this linked list, right? Reform this linked list into something like this, 8, then even 2, then even 4, then 6, and then all the odds, that is 17, 15, 9, right? So you can see first all the evens are coming, that is this is even, even, and then all the odds are coming, now certain things are to be seen, right? First scene is that you cannot create new nodes. Do not create new nodes, right? Instead rearrange them, that is 8's next will be 2, right? I cannot make a new node and then form the 8 next, like this pointer, this node is actually equal to this node, this node is actually equal to this node, etc, etc, right? Do not create new nodes. Second thing is even should come before odd. All even should come before all odds, as you can see, that is pretty evident. Third thing is that relative order should maintain, relative order of both even and odd, should be maintained, should be maintained, right? Okay, so what does that mean? That is 8, 2, 4, 6. 8 is occurring before 2, 2 is occurring before 4, 4 is occurring before 6, and similarly 17, 15, 9. 17, 15, 9. The relative order between evens and the odds are same, right? Only the relative order of even and odd is changing, but even and even are on the same page, right? Now these are the 3 points you have to keep in mind while solving the problem, and then you have to give me the answer, right? Okay, now how will you solve the problem? Okay, if this condition was not given to me, if the first condition that I can create new nodes was given to me, then what could happen? Then it is very simple. What will I do? I will first traverse a linked list, right? So I will keep a temp pointer here, and then I will traverse. I will traverse in this direction. As soon as I encounter a even node, I will make a even node. As soon as I encounter a even node, I will attach it. As soon as I encounter, I attach it. As soon as I encounter, I attach it, and then I will traverse again. I will keep temp again here, and for the all the odd node, that is my linked list was something like 8, 2, 4, 6, and then for 17, 15, 9. This will give me the new nodes, but the space complexity here will be O of n and the time complexity will be O of 2n, right? But do not create new nodes is evidently trying to say me that I have to do it in O of 1 space complexity, right? So how will I do it? Actually very simple, right? Now another thing I have in mind is if the O of n, like I'm not creating new nodes, but I'm storing it in some way. How? So I said that every linked list question can be done easily using a vector. Let me mention it again, every linked list question can be done using vector, using vector. This is a hacked version, this is a hack, right? Right? Okay, this is not the version that interviewer would like you to solve, but if the question comes in an OA and you're not able to solve using the linked list, then vector is a way you can go through, right? Because in the OA you have to just give your answer, but in the interview do not try to write this approach, right? Okay, now if I try to do this, then my linked list looking something like 17, 15, 8, 9, 2, 4, 6. So I will create a vector which will look something like 17, 15, 8, 9, 2, 4, 6. Now, in the case of vector, it is very easy. What will I do? I will make two vectors out of this. First vector will contain all the odds, and second vector will contain all the evens, right? 17 odd, so push here. 15 odd, so push here. 8 even, push here. 9 odd, push here. 2 even, push here. 4, 6. Now it is easy. I want even to be coming first. Now what will I do? I will keep a temp here. I will keep a temp here. I will keep my I here at 8. Now what will I do? I will just start filling values. That is, in the original linked list, in this linked list, change the values. Do not create new nodes, but change the values, right? So what I'm saying is, my approach is, do not create new nodes, else change the value of existing nodes, right? Something like this. The linked list which was given to me was 17, 15, 8, 9, 2, 4, 6, right? Now I am saying, let us say this is my linked list, right? What will I do? I will just change the values. That is, I will start from here. 8, I will change 17 to 8. 2, I will change 15 to 2. 4, 4, 6, 6. Then odd value, 17, 17, 15, 15, 9, 9. And you can see this is a linked list which we wanted as an answer, and you have got the linked list. But the space complexity is still O of n because I am using an extra vector, right? And the time complexity is O of n. O of 2 n actually, because I have to traverse one for the filling of the vectors and second time for filling the linked list again, right? So O of 2n. Okay, no better approach for, like, this approach is not better in any case. The space is again O of n, the time is again O of 2n, right? So what can I do now? What can I do? I can try to do something which will work in O of n and O of 1 space complexity. My time complexity should be this, my space complexity should be this. How? As the question says, rearranging. I will do something like rearranging. But how? On what basis? On what basis? So the answer, my approach comes from this approach only. From this approach, odd and even. Odd and even. So my given linked list to me was 17 connected to 15, connected to 8, connected to 9, connected to 2, connected to 4, connected to 6. Right. Now, up till now, we have solved many questions using dummy, right? But in this video, I am going to create two dummies. I am going to create two dummies. First with -1 value that will be named as even. Second with -1 value that will be named as odd. This will be A1, this will be A2. Right. Now what? I will keep my temp pointer here. I will keep my temp pointer here. I will check the value. Temp contains a value that is odd. So attach it. 17 comes here, A2 comes here, and then it is become null. That is, this connection is broken off. Temp is now here. 15, again odd. 15 here, A2 here, this connection is now broken up and temp is here. 8 is even, so attach it here. 8 is even, attach it here. Okay, after attaching, A1 will come here, temp will come here, and you will break this connection. 9, again an odd value. So 9 comes here, temp comes here, A2 comes here, break this value, right? Okay, again 2, 2 comes here, temp comes here, A1 comes here, and break this connection. Temp 4, again even. So 4 comes here, temp comes here, A1 comes here, break this connection. 6 again. So 6 comes here, A1 comes here, temp becomes null now, and I will break this connection which is not existing anymore. Now this is done. Now this is done. And I have got my linked list of evens and my odds, right? Now what can I do? What can I do? I will just attach this. A1 is actually pointing to the tail of even. A1 tail of even linked list, right? I will have to attach this node to this value. So what will I do? I will say my odd head is equals to odd next. Odd head equals to odd next. Now you can simply delete your odd value, delete odd, right? This is deleted. Now moving on, I will say A1 next equals to odd head. That is, this connection is formed, right? Now the only thing you have to do is delete this node and your answer will be this node. That is, my head equals to even next, head equals to even next, right? And now you can just say delete even, and you can return your head, return your head. That will be your answer. You can see 8246 1759 is the answer we wanted. And for the grace of God, the space complexity is now O of 1 because I have not used any extra space. I have just made this node travel here, this node travel here, this node travel here. These are the just the traveling, right? These are not using any extra space, and the time complexity is also O of n. So this is a better and the optimal approach for the problem we discussed, right? Okay, what is the pseudocode looking like? Pseudocode is actually very simple. Discuss the dry run. Let us discuss the pseudocode now. Usually it is in the reverse direction. Sorry. Okay, now what I will do, I will say e1 equals to new node with value -1, a1 equals to e1 for traversal. Similarly, odd equals to new node with -1 and a2 equals to odd and temp equals to head. Now start the traversal. So while temp, that is temp has not been become equal to null, what will you do? If temp data percentile 2 equals to 1, that is added into the odd. So a2 equals to a2 next, temp equals to temp next, a2 equals to temp, sorry, a2 next equals to temp, a2 next equals to temp, a2 becomes a2 next, a2 equals to a2 next. Now before breaking the connection, temp will move forward, that is temp equals to temp next. You can just do a2 next equals to null, and similarly in the else case you will just replace a2 with a1, right? And at last you can just make the connection, make the connection, right? Now I think that showing the code to you will be much easier, right, than writing the pseudocode, because these are actually very same, right? Okay, now let us move to the code. But if any problem is left for you, you know where to comment me. You can DM me in the social media handles as well. So I will write request you to please connect with me on the LinkedIn, right? Follow me on Instagram, right? And you can DM me your problems there. I will surely get back to you within no time, right? Okay, so let us move to the code. Also you can comment, right? That will engage my engagement as well. Okay, you can comment down also, and if you like the videos, please please press the like button, and if you are new here, do not forget to subscribe. Do not forget to subscribe. Let us move to the code now. Alright guys, so here is the coding section. Okay, so let us, without wasting your time, let us start to code. So first, node star even, right? Let us name it as even dummy. Even dummy equals to new node with value -1. Similarly, node star odd dummy equals to new node with value -1, right? And node star a1 equals to even dummy and a2 equals to odd dummy. Now what will you do? You will say node star temp equals to head for the traversal. While your temp is not null, while the values are present in the linked list, what will you do? First case is if temp data percentile 2 equal to 1. That is, you have to add this node into the odd linked list. So a2 next equals to temp. a2 becomes equals to a2 next for the further additions. Temp becomes its next. Temp equals to temp next. And you can just break the connection. So a2 next equals to null. Similarly, else case, I will just copy it down because I just have to change a2 to a1, right? Right, okay. It will be a1 here, a1 here, a1 here, and a1 here, right? Okay. Now, what do we do? After this loop, what will I do? I will say uh, a1 next equals to or dummy next. Form the connection, delete your or, delete or dummy. And now you can say head equals to even dummy next. Safely delete your even dummy. Safely delete your even dummy and return the head. Return the head. Right? Okay. Let us try to compile and run it. Hope it will work fine. Should not give any error. Oh, it is giving some error. What is the error? Node star a1 equals to even dummy. Is giving. Oh, it will be star a2. It will be star a2. Let us try to compile and run it now. Should work fine. Okay, working fine. Let us try to submit as well. Please work fine. Okay, it is running. Okay, and it is getting accepted. So thank you for watching. We'll meet again tomorrow. Till then, please stay tuned, keep coding and keep hustling.